Hello, guys. Thank you for joining me on this lovely Wednesday morning over here on the East Coast of the United States. My name is Aaron Eberhard. I am the multi-axis and hole-making product owner for CNC Software. The focus of this presentation is going to be on how to utilize stock. We're going to be focusing on Port Expert at first, but I really want to drive home the point that just about every toolpath, especially ones that could rough, really benefit from using stock. So we'll be showing a couple of other examples as well. The part we're going to be focusing on today is a part that we made in association with the UConn, which is University of Connecticut FSAE, the Formula SAE program. A little background on this. This is a car that they have to build every 2 years. They have to build a completely new car as part of this university program. And of course, it's teaching all sorts of automotive engineering. It's sponsored by a lot of the big car manufacturers. And what they do with this car is they take it to a track and they do an autocross style or Gymkhana style race where you race through cones. They have engineering competitions. There's all sorts of things that they do with this car as far as competition goes. And these are schools all over the world that come for these competitions. What we're going to be focusing on right now is one part of this car that we helped make, which is this upright that supports the wheel hub, which the wheel is bolted to. And you could kind of see it peeking out a little bit, excuse me, on this picture. Well, guess you can't really, sorry, but it's the part that's inside of here that these upright, the A-arms are connected to. So let's take a look at what we got. I'm going to be using Mastercam 2021 for this demonstration, although these concepts do apply to any version of Mastercam that you're using. And honestly, the concepts apply to most toolpaths inside of Mastercam as well. So try and think a little bit outside the box more than what we're just looking at here today. So this part, like I said, this would be oriented in the car this way. The wheel hub would go in here, and then the wheel itself would be bolted to that wheel hub. We're going to be focusing on a particular pocket, although this same challenge existed in multiple positions around it. And for this part in particular, we're going to be focusing on using the Port Expert toolpath. Now, some of you guys may have seen that Port Expert toolpath used for cylinder head porting or manifold work before, but this is a really great and unique case to really leverage some of the unique capabilities of that toolpath. So we're going to be focusing on this purple pocket right in here. And we're going to be joining what would happen after we had already done all of our 3-axis roughing. So we would have roughed this out using Mastercam's dynamic toolpath, and we would have ended up with a stock model, something like this. Now, if you look at this from the outside, it doesn't look like it would be that hard to come in here with a Lollipop tool and just clean up this pocket. But there's a couple of things that you need to keep in mind here. Lollipops really do not like center cutting. They chatter, they cry, you could deflect them. It's really not great for anybody to use lollipops for center cutting. And there's actually a little more material here than you would expect. I'm going to edit this section view, and we're going to take a look at how much material we're going to be removing in here. Now, before I do this, I do want to show you guys, if you haven't played with section views in Mastercam, this is an extremely powerful tool. Real quick, I'm just going to take off the stock model and just show you that in the Planes Manager, there's an option for section view. If you turn that on and you have display section view turned on, you're going to be able to trim your view to whatever view you've chosen. Really great capability, lets you look through, basically right through the part. The other fun thing about it is it's live. So I created a plane here just to have a section view. And if you edit that view, it is a dynamic sectioning tool. Really, really great capability. And in this case, we're going to use this to see inside of the part and take a look at what this stock model looks like. All right, so there's our stock model. Our section view's on. I'm just going to come back here to edit that. And I'm going to adjust it in the Z. So what we're looking at here is this overlap is material. We could see our port shape pretty clearly defined, nice and clean, and then we're getting that extra material right there. So let's go in a little further. This one isn't too bad. I mean, honestly, a finish pass will probably clean that up okay. But as we start to get down here into this corner, look at how much material we're leaving on the table there. So your Lollipop tool is not going to like finishing that much material, and you're not going to get a good finish. So what you would end up having to do would be to run your finish pass multiple times. You'd run a complete finish pass maybe with some material to leave, and you'd still hear that tool screaming down in the corners because it really would not like engaging that much material. So let's take a look at how we set up a Port Expert toolpath in the first place, and then we'll talk about how to leverage some stock with it. In this case, let's go back here. I'm going to let's turn off my stock model for a second. And we're just going to look at this model itself. One of the things you're going to notice is that the entry into this pocket is not exactly clean. There's, a bunch of complex fillets here. And you guys, I'm sure, anyone who's been programming Mastercam for a while has gotten models like this. Maybe they went a little crazy on the fillets or they didn't apply them in quite the right order, and it really creates some messy geometry. And of course, this pocket does not have a nice even edge, so you're going to have some problems creating a clean pass there. I find the easiest thing to do in a situation like this is to just take these surfaces and untrim them and clean them all up. Now, we're not going to get into geometry manipulation in this presentation because we're really focusing on the use of stock in these toolpaths. But we do have some other webinars that would help you with surface creation and manipulation later on. So let's take a look at what I made for my drive surfaces here. So basically, as you could see, I just created surfaces from this solid, and then I took the curve around the edge and a flat surface here that was just kind of a little bit of a cone, kind of maintained the shape but didn't overlap with the solid at all. I didn't want to cut the solid. And I just basically lofted some straight sections down there. And I also allowed that to create a little fillet there in the corner, and that's what I'm going to use as my drive geometry. Now, another thing you could do for calculation purposes is to isolate collision detection or collision surfaces that you don't want to hit. It's going to add a lot of computation overhead to tell it to collision check against some of these areas over here, when of course machining the port is not going to have any danger of hitting this stuff over here. So again, I just isolated a few of them to kind of keep the computation time down a little bit. Create the actual toolpath itself. I created a port machining toolpath here, and that's going to be found under Port Expert is under your toolpaths group and Port Expert here. So that's what we're going to be looking at. The setup type for this is pretty typical at the first part. So we're going to have a tool defined. This is my Lollipop that I'll be using, and that's an off-the-shelf part. Properly define your holder. Of course, any of these toolpaths, especially in multi-axis, as you guys know, you really want to have your holders defined properly, or else collision control doesn't mean anything. So we're using a shrink fit Cat 40 tool holder based on our machine in this case. Now, I want to show you what this toolpath looks like without stock. So for now, we're not going to be using the stock page. We'll go back to that in a second. Well, let's take a look at the cut pattern so you know what I've chosen as far as my settings and everything. For my pattern, obviously, the focus of this is roughing. So unsurprising to anybody, I've chosen the roughing pattern. I've chosen the dynamic style motion. I do not want the offset style, and you'll see the picture change if you choose the other one. And then the machining surfaces, I just chose these, like I said. That's the surfaces I created for it. I do want to leave a little bit of material on there. In this case, it's an inch part, so I'm leaving 10 thou. Other than that, I did tell it I only want to machine from one side. So that's going to tell it just machine from this one side and get as far as you can. Naturally, Port Expert tries to machine both sides of a port. Of course, we can't get in there and machine this other side because there's material in the way and it wouldn't be able to fit the tool in there. So I did top, maximum, top. Other than that, these are all just step over settings. I personally went with 1 thou cut tolerance, maximum step over here, and that'll be situationally dependent based on what your settings are. All right, tool axis control, nothing much to adjust here with Port Expert. 5-axis, minimize tilting. And the only other thing I really had to play with was on the collision control. I left all of my clearances at default because that was fine for this particular instance, but I did have to include some check surfaces here. And of course, as we already talked about, my check surfaces were these individual faces that I was kind of worried about hitting. All right. Other than that, everything else is out of the box for my Port Expert Toolpath. So let's take a look at what we ended up with. So the toolpath for roughing without stock defined is going to assume that this is just a big solid billet piece. In this case, we know that's not the case. You've already seen the stock that we've roughed out in the 3-axis toolpaths beforehand. So you know that this is already not optimized because there's a ton of air cutting here. But the other thing to notice here, and my step down's a little fine, so we'll just kind of clean up that toolpath a little bit. But the other thing here is that we have to helix down and create our own bore to rough into. If you've ever worked in a shop cutting on tip with some lollipops, you know how noisy and obnoxious that is, and it's not great for the tool. And honestly, if your fixturing and your part are a little less rigid, it's really not good for that either. So there's a lot of reasons not to use this. On the other hand, you can see, I'm just going to keep trimming it here as we go, and let's make this translucent so we can see through. You can see that the toolpath gets all the way through and generates a very safe, clean motion. It's just not the most efficient because we know where that stock is. So that's really the meat of what we're trying to show here. What happens when we turn on stock? So of course, we've already seen the stock model. We've already looked at the material left. The only difference I had to make for this toolpath, this is just a copy paste, is to come down here and choose stock. I just told it to use stock, and then I told it to look at what stock model I wanted. Of course, for the case of the presentation, this is a very focused thing. I only had one, but you could choose from the drop-down other ones. I did not change any other setting, so I'm not going to bore you by going through other pages. So now, when we look at this toolpath, the first thing I'd like you to notice here is just the raw size of the toolpath. The original one is basically 21 megabytes of NCI data, and this one is about 4.5. So we've already removed 75% of the code coming out of the machine. So now, as we come down this path, what I'm going to do, I'm going to change my display just a little bit here. Make that solid for a second. What I want you to notice is that it's not wasting time helixing in anymore. It knows where the stock is, so it's going to plunge down into open air, and then it's going to ramp into the material and cut all the way around. Once it isolates an area that needs a little bit more work, like down here, you're going to see it do that beautiful dynamic helixing in. And then we'll clean up this corner and over there, and now we're going to spiral down to the next one. Again, we can move through the air because we know where it's safe and where it's not. And as we move down this toolpath, I'm just going to trim this up. And you can see here we're really engaging some good material there and cleaning out that pocket. So let's take a look at what that would look like in our simulator. Now I do want to make sure that my simulator is set up correctly. So we're just going to take a quick look. I am using my stock model as my stock. I have my fixtures already defined as level 500, and I should be good to go. So we're going to just take this and verify that.
Hey, Aaron, you do have a question.
All right. And okay, so great question while we're looking at this. And the question is, what can Port Expert do that the regular port path cannot? And so I will get back to that in a minute, Adam, and that is an excellent question. Let's just finish this verification and then I'll loop back to that one. All right. So as expected here, speed this up just a little bit to get to some interesting parts. And we'll display the toolpath as we go. So we're just going to helix down here, jump. I'm just going to pause it. And we're going to jump ahead to maybe a little more interesting place where there's a little more material. There we go. So here you can really see how well this is working out in these corners. All right. So what I'm going to do is I'm going to leave this calculate in the background so that way you can see what this end result looked like while I answer Adam's question. So I don't know if everybody else can see the questions, but the question was, what can Port Expert do that the regular port toolpath cannot? So the regular port toolpath that he's talking about is up here. It's kind of a more generic toolpath. And the concept of this one is that this is an old toolpath, just so that way, in case anybody doesn't know, I believe this came out in the late 90s. But basically what this is a flow toolpath that can compensate inside or outside based on what direction you give it to compensate to. And that's all handled down here on the collision control page, whether you're expanding up or expanding down. It was trying to solve the same problem that Port Expert does, but it didn't really handle it as elegantly. With this one, like all of the old school toolpaths, you are responsible for making chains that drive it. And so you can either do like from point to point or drive it from a chain, et cetera, et cetera, et cetera. Now, with the Port Expert toolpath, so let's go down here and check out Port Expert. This toolpath is designed to automatically calculate the most efficient motion through a closed shape. So that's going to include that you could rough out, obviously, that's the purpose of this demonstration, but it also includes finishing along or finishing around. It automatically could determine a path through the port, so you don't have to split your surfaces and do a ton of prep. You can manually choose a path if there's multiple paths. So in the case of cylinder heads, there's oftentimes 3 or 4 2-valve ports. Or in the case of manifold work, there's often intersections with multiple intersecting manifolds, so you could choose a manual path through it if you wanted to. It's designed to automatically figure out whether you can get both sides all the way down. You could control exactly how fine that is. But really the biggest thing about this, and then of course the tool axis control, like I said, it automatically tries to figure out the most efficient motion where it's going to keep that tool perpendicular unless it has to tilt. Excuse me. So this is really geared specifically to solving that port problem, and it is significantly faster and easier and more intelligent than the port toolpath. And to follow up your next question, which is Lollipop the only tool you can use with the Port Expert toolpath? No, not at all. The big thing is that it does have to have a radius. So you can use a ball mill or even a bullnose in the roughing algorithm. In the finishing side of the algorithm, you could use a ball or a lollipop. So you can't get away with a sharp corner end mill. So you do have to have a little bit of a radius there. Otherwise, it wouldn't be able to tilt and maintain any sort of contact with what it's trying to do. Does that help out, Adam? Okay, cool. So looking at this, here we can turn off our toolpath. You can see even all the way down through here, all we're doing through the air is linking around, and that removed all of the material quite nicely. So with that, does anyone have any questions on this particular application of it? And if not, we'll jump into the next one. Are there plans to introduce support for accelerated finishing? Possibly. We've looked at doing that, and I've done some studies working with the developers and everything. The problem that we run into is that there's a lot of cases where the accelerated finishing tools don't work, and they require a lot of really crazy tool axis control. So we're trying to figure out whether on the narrow scope of parts it's worth it, or maybe the other way around will be to really limit the type of accelerated finishing tools. Because the problem that you have machining these ports is that you have to basically end up with a barrel style tool, because you have to be able to undercut to effectively use that inside of a port shape. And a lot of the barrel tools don't have an undercut, like the tapered barrels and things like that. So possibly, maybe, depends on whether we, whether we find that it's applicable enough or whether it would just be annoying. So the question from Sergio is, can the tool be set to concentrate on roughing an area only where there's a lot of material to remove? And absolutely, but you're going to want to control that based on the stock you give it. And I'm going to have a great example of that in play 2 files from now. Yeah, Sergio is also suffering sometimes that the toolpath doesn't cut all the way through the port or even the edges. So in that case, I'd recommend sending in a file. Oh, that's another Sergio, sorry. But I'd recommend sending in a file to tech support QC or post it up on the forum. There's a lot of reasons that it can't figure out a path automatically forward. And sometimes it's intuitive and you can understand why based on your tool selection or the amount of clearance or whatever. And sometimes it takes a little deeper understanding. And once it's pointed out to you, oh, it didn't work because of this, it's a great learning opportunity, and you could hopefully pick something up from it. Okay. And follow up with your reseller and make sure that anything gets sent in, and feel free to have it addressed to me, and we'll take care of you. All right. So someone said makes sense now. Okay, good. So let's take a look at another application here. And this one I'm not going to spend as much time. It's going to be the Port Expert Toolpath. Again, this is just a slightly more common use of it. And I wanted to make sure you understood that this kind of technology, even if you're not doing crazy formula SAE stuff, still applies if you're doing things like manifolds and port work. So this is a fairly typical manifold from a 4-cylinder car. Coming in, this would be the side that attaches to the cylinder head, and this would go out to your intake wherever. So normally when you get these things, in this case, if you're making it from a billet, you're likely to end up with a shape like this, where you end up doing your finish work and then you're finally ready to fixture it and machine your stock. Most of the time when you do something like this, again, going back to that, lollipops really don't like to center cut, you could either do some 3-axis roughing paths and try and clear it out, or what most people do, just because it's a little more time efficient, is they end up drilling. So they'll set up 2 drill tool paths that just punch a big hole all the way down and all the way down. Of course, you'd link it properly, but that'll give you a stock model that looks something like this. And you can see it removed the majority of the material from the port, and it gives a path for coolant and chips to go through. So to come back here, I created a Port Expert toolpath on this gray surface. I'm not going to bother you with setting up the toolpath. You saw that before. If you have any questions, I'm happy to show you. But basically, I'm machining the gray surfaces. Now, looking back at what we found before is it starts in the middle and it has to helix all the way out. But of course, there's a ton of wasted motion there. And the other thing about this that I'd like you to focus on is that it has to, let me just get to the end of one pass here. I'm going to trim off that pass and we're going to look at how it gets down to the next pass. So Port Expert is smart enough to do a nice spiral down between these passes, but of course, that's all going to be really noisy and hard on the tool if this were solid billet. In our case, all that is just wasted time. If you could plunge down there, you wouldn't have to play with feed rates, you'd be able to run a little more aggressive, and you'd know that you weren't engaging too much material. So again, putting on stock means that our toolpath is going to be able to plunge down in air. Notice how straight that plunges because it knows where the material is. So it knows that it's safe to plunge straight down, and we're going to spiral around as we come down. I'm going to, let's see here. Let's just take a look at a section view of this guy. Oh, I hit the wrong one. I'm sorry about that. There we go. So again, we could see that it's a nice, efficient motion all the way through. And really the biggest thing about this is just that we're removing the leading and the trailing, lead in and lead out kind of movement between slices and a little bit of the inside. So slightly more efficient. Basically the same application, but this is very, very real world for a lot of people that do manifold work. And I don't want to keep you guys too terribly long, but one thing that I'd like to stress is that this kind of thinking and application really doesn't apply only to Port Expert. Of course, that's the focus of this presentation, but I'm going to show you a roughing example. Now, one note, if you haven't switched to Mastercam 2021 yet, multi-axis roughing is now multi-axis pocketing. And the reason for that is we've expanded out the capabilities of this toolpath to really focus on those accelerated finishing tools. So now inside of pocketing, we could do roughing, we could do floor finishing, or we could do wall finishing. And if you do wall or floor, you're going to notice a new tool axis control page that really lets you control where the maximum contact point is. That's going to be the focus of a future webinar. And also, if you go onto our forum right now and look at the 2021 What's New, I walk you through how to use some accelerated finishing or barrel tools using those new options. For the focus of this webinar, I'm really going to be focusing just on the roughing side of things and answering one of the earlier questions about how you could get it to be more intelligent about using local stock and things like that. Before I get into that, the last Port Expert question it looks like was, does it make a difference if the CT planes are different than the WCS? In general, no. This has a very big asterisk next to this. But in general, for most machines and most posts and most configurations, the WCS is all that it's really looking at. That being said, if you're using an aggregate head tool or your machine configuration is different, that may not apply. In general, I highly stress to people that when working in multi-axis, you keep all of your planes and your WCS consistent with everything else that you want. The other time it might make a difference is if you're using a horizontal machine where your WCS is being rotated 90 degrees, so you actually program like a top front front or top back back or top right right or whatever. In a normal scenario, you want to make sure that your multi-axis paths match that in case your post is doing some sort of coordinate system rotation. Okay, so sorry about that. I just wanted to hit that before we lost. All right, so now let's take a look at a roughing example on something like this. And I'm not going to dig too far into every individual parameter. We will be giving a brief overview. But the idea of a part like this is that we need to rough out this pocket. Now, this is a big advantage of using stock because as a human, you look at this part and you think that, okay, my part's going to be something like this when I start, and I'm going to need to machine out this pocket. But what we give the algorithm to crunch on is we say in the roughing that these green walls are our walls. They're our vertical section. And this is our floor. Down here, this red surface down at the bottom. So basically what we've given it here, if you don't tell it stock, is here's the walls, here's the floor. And if you generate a toolpath off of that, you're probably going to be fairly disappointed with what you get, because it's going to come in here and basically with the step down I've given it, it's only going to be able to machine one pass on the floor. This is less than desirable, to put it nicely. Why is that? What happened? Because I did not give this example stock, it had to figure out where the volume of material to remove is. So what it's going to do is it's going to try, and my mental analogy here is to fill it with water. Pretend you filled it with water and it was level to the floor. If you did that, it would all run out of this lower corner right here. This corner is very, very shallow compared to the back. But when it's calculating volume, it can only do it where the walls contain that volume. Otherwise, it has no idea. I mean, is this a big rectangle that's starting out of a pure forging? Is this, or a billet chunk? Is this already a forged model maybe, or a forged part like this? It has no clue. And so this is where, if you don't define the stock, you're not giving the algorithm enough information to give you results that you'll be happy with. So I just want to show you a couple ways to resolve this problem. One of them is to create a local stock here. And you can do this very easily with the model prep tools. And I know there's other webinars and examples, so I'm not going to show you how to do that. But I do want to show you that, it's pretty easy to make a plug for a specific segment. And at that point, if you tell it, this is my stock, this is the toolpath you're going to get. Look at how beautiful that is. It knows where the air is. It knows that it needs to start high and work low. And it also knows that it could plunge out here and be safe. And then it could just kind of spiral away, just like you'd want it to. There's a couple other ways to do this. So this also works in Port Expert. If we were to make a port that only had the corner that had, or a stock that only had the corner that had material there, it would focus only on that area. So another way to do this is to choose an entire forging or your entire stock like this. But you run into a problem sometimes where if you give it too much stock and too much freedom, it's going to go everywhere it can. I know this is the roughing toolpath, but Port Expert and every other one can overrun the same way. So you see this spreads all the way out to the edges. So if you start playing with these and you're feeding it a ton of stock that goes a lot deeper than you expect or whatever, you may end up choosing some containment. So in this case, I selected the solid, but I did make this curve just to kind of show you the containment. Here's that same exact toolpath if you enable containment. Now it's limited to the stock that you intend to cut. And I'd like you to take this away really from this seminar, is that this stock is really, really important to the 5-axis toolpaths, but it's also the same sort of thing you could do with 3-axis finishing and 5-axis finishing as well, where if you're trying to do like a pencil machining or something and you're trying to clean up only this fillet, if you create a stock model that just adds a couple of thou or a millimeter or two off of this fillet in the corner, you could create a toolpath that starts all the way up here and ends all the way down here, and it will be trimmed down to that corner. So this, obviously, what we've talked about is 5-axis, but this applies in 3-axis as well. Any place that these toolpaths can have that stock turned on, this is something you could leverage to really make your toolpaths more efficient. All right, well, thank you guys for attending. I'm glad you guys all had fun. I hope you learned some stuff, and this applies to all of the toolpaths. I'm going to end the presentation now. Have a great day, everybody.